Okay, so our triangles will be similar, and we're going to look at special segments within those triangles and their similarity. So I want you to recall back in chapter 5, that's where we had a lot of vocabulary words that you weren't used to before. We had angle bisectors, medians, altitudes, and perpendicular bisectors, right? Those were special segments within our triangles. So just as a refresher, what each of those are, in this first one, an angle bisector would bisect your angle. Okay, so it splits it into two congruent pieces. So at point A, that angle A would be split into two congruent pieces. That's an angle bisector. A median goes from your vertice, so point A, to the midpoint of your opposite side. So you need a midpoint on your opposite side from A. Okay, meaning those two pieces are congruent, and it connects your vertice to that midpoint. Okay, so that would be a median. Okay, number 3 is an altitude that again goes from the vertex and is perpendicular to the opposite side. So we're going to go from our vertex, angle A, and perpendicular to the opposite side. Okay, so these are 3 special segments that we can use in similar triangles. You can't use the perpendicular bisector, which we also talked about in chapter 5, because it doesn't connect to the vertice. Okay, all 3 of these ones do connect to that vertice within your triangle. Perpendicular bisector doesn't necessarily have to. Okay, so when 2 triangles are similar, their corresponding altitudes, angle bisectors, and medians are proportional. Okay, so our 3 special segments here, altitudes, angle bisectors, and medians, are proportional to those corresponding sides within similar triangles. Okay, so since these triangles will be similar, we can set up proportions to find those missing side lengths. So in example 1 here, we have in the figure triangle ABC is similar to triangle XYZ, okay, with angle bisectors shown. Okay, so this segment BD and YW, those are both angle bisectors. And we want to solve for X. So since these are similar triangles, that means their special segments are also similar. So if I want to solve for X, which is right here, we want to set up a proportion just like we've been doing in the past. Okay, so I can take side AB, which is 24, over its corresponding side in my similar triangle. So making a ratio of your corresponding sides, that would be X. Okay, that's equal to, since I started with 24 and that was in my first triangle here, I need to start with 10, which is in my first triangle again, over its corresponding side, my second triangle, which is 8. Okay, so again, we're just setting up this proportion with similar triangles to solve for that missing side length. From here, we're going to cross multiply. Okay, so we have 10 times X and 24 times 8, which is 192. And then all I have to do is divide by 10 on both sides. And that X value will be 19.2. Okay, so very similar to what we have been doing these past few sections, right? Setting up a proportion, cross multiplying, and solving. Okay, any questions on how I set up example 1? All right. We do have some more examples here. Now before I start setting up proportions, what I want you to do is tell me what the special segment is within these two similar triangles. So number 1, what type of special segment would this one be? It's a median. Okay, so that special segment is a median. Since it is a median, it does correspond and is proportional with those sides, okay, of those similar triangles. So from here, we can set up our proportion. I'm just going to start with my first triangle here. Okay, this side is 36. What's its corresponding side? 18, so I'll write 36 over 18. It's equal to, what ratio is that one equal to? 20 over x. Good. Not so bad, right? Okay, from here, cross multiply. So we have 36 times x. To get 36x is equal to 18 times 20. That's 360. Divide both sides by 36. To get x is equal to 10. Alright, I want you guys to do 2, 3, and 4. I do want you to tell me what the special segment is. Okay, it has to be one of the 3 from above in order for you to set up a proportion. So it can't be a perpendicular bisector, so don't label it perpendicular bisector. Okay, so first label what your special segment is, and then set up a proportion to solve for x. Yes. All right, I'm going to start looking at 2, 3, and 4 because I think most people are finishing up with those ones. So number 2, what type of special segment is drawn into these two triangles? An angle bisector, good. Okay, so you may have set up your proportion different than I do, but you'll still get the correct answer because you could flip-flop them or start with a different one. So I'm going to start with 12. Over its corresponding side in my similar triangle is x. That's equal to the angle bisector in the first triangle is 9. Over its corresponding side in my second triangle is 6. Okay, from here, cross multiply. So I end up with 9x is equal to 12 times 6 is 72. Divide both sides by 9. And x is equal to 8. Okay, so number 2, you should have gotten x is equal to 8. Okay, number 3, the special segment drawn in both of these triangles is an altitude. Okay, so you should have had altitude for that one. And again, setting up my proportion, taking one side from my first triangle here is 4. Over its corresponding side in its similar triangle is 3. Okay, that's equal to taking the altitude from the first triangle, since that's the one I started with. That was 3. Over the altitude in the second triangle is x. So from here, again, I'm going to cross multiply. So I have 4x equals 9. Divide both sides by 4. And I got x is equal to 2.25. Okay, last one, number 4 on the front here. These two special segments drawn in, they're not inside the triangle, but they still are a special segment of that triangle. It is an altitude. Okay, remember, altitudes can be drawn on the outside of your triangle if it is an obtuse triangle. Okay, so your altitude can be drawn in on the outside when it is obtuse. So here we're just going to set up the proportion the same way. So taking the side from your first triangle of 10 over its similar side in the corresponding triangle is 8. Okay, that's equal to the altitude of the first triangle, x, over the altitude of the second triangle, 7. Okay, cross multiply, I get 8x equals 70. Divide both sides by 8. And I got x is equal to 8.75. Questions on those 3 that I had you do? Are we feeling okay about our special segments in similar triangles? Again, it's the same process that we have been doing, is setting up that proportion and then solving for that missing side. All right, then we'll skip over 5 and 6, just because I think you guys are pretty much understanding what's going on in that section. Okay, the next part is talking about angle bisectors specifically in a triangle. Okay, so we have the triangle angle bisector theorem. It states an angle bisector in a triangle separates the opposite side into 2 segments that are proportional to the length of the other 2 sides. Okay, so this angle bisector separates your triangle into proportional parts. So we can again set up a proportion. You'll just have one single triangle, and you have to make sure it's with an angle bisector. So in our first example here, we want to solve for x, okay? And I have SU is a angle bisector, okay? This angle bisector separates that triangle into proportional parts. So I can look at this first triangle here, RSU, and take that side of SR, which is 15, put it over, looking at my second triangle, UST, its proportional side would be 30. Okay, so I can write 15 over 30 is equal to, since I started on the left of this triangle, I'm going to start with x in my second ratio over its proportional side in that other, on the right-hand side, is 20. Okay, so I have 15 over 30 equals x over 20. Okay, so it separates, that angle bisector separates your sides proportionally. So again, from here I can just cross multiply. So I have 30 times x, so 30x. is equal to 15 times 20 is 300. Divide both sides by 30. And you should get x is equal to 10. Okay, questions on that example using the angle bisector theorem and proportionality. All right, then I want you to do 1 and 2, and then I'm going to go through 3 because that one's a little bit different. Okay, so do numbers 1 and 2, and then I'll go through those, and then I'll go through the rest after. All right, so I did numbers 1 and 2. Okay, so my proportion, I have 25 over x because those are your corresponding sides cut by that angle bisector. And then I have 20 over 28. Since I started with the left, I again have to start on that left-hand side. Then cross multiply and divide by 20, and x is 35. Number 2, same thing. You have that angle bisector, so it splits it proportionally. So I can write out my first ratio as 15 over 9, and then my second ratio is a over 3. Okay, questions on 1 and 2? All right, then before I look at 3, I want you to look at 4. Okay, number 4, again, we have an angle bisector, right? But I have this entire bottom length here, correct? Yes. So I need my corresponding pieces. So what would this piece have to be? 5. It would have to be 5. How did I get that? I subtracted. Okay, so I took 15 and subtracted 10 to get that missing piece there. So now that I have my pieces of my proportion, I can set up my proportion. Okay? So again, I'm just going to start on the left. So I have x over its corresponding side, given that angle bisector is 13, is equal to, since I started on the left, I'm going to start with 10, over its corresponding side on the right is 5. Okay, so again, cross multiply. We have 5x is equal to 13 times 10 is 130. Divide both sides by 5. And x is equal to 26. Okay, I wanted to do that one first. So now I'm going to look at 3. So at number 3, I have one side that's n, okay, and I know the entire length here. So how can I figure out this piece right here? How did I find this 5? I subtracted. So I need to take this entire length of 46.8 and subtract n to get that smaller piece there. Okay, it does not split it in half. This is an angle bisector, it is not a median. Okay, so both of those pieces are not n. Okay, it does not split it into two congruent pieces. So don't make that mistake. You need to take the entire length of 46.8, subtract the piece that you know, which is n in this case. Now I can set up my proportion of corresponding sides given that angle bisector. So I'm going to start on the left again here. So I have 36 over its corresponding side on the right is 42. Okay, that's equal to, since I started on the left, again, I'm going to start on the left, so that's this section right here of 46.8 minus n over its corresponding side on the right is n. Okay, from here we're going to cross multiply, so I have 36 times n. Don't forget to distribute this 42 to both terms. Okay, so we have 42 times 46.8. That is 1,965.6. And then you also have 42 times n. So we have minus of 42n. So I'm going to add 42n to both sides of my equation to get 78n is equal to 1,965.6. And then I'm just going to divide by that 78 on both sides to get n by itself. And I'll end up with n is equal to 25.2. Okay, any questions on how I did 3 or 4? Are we good? Do we need to see another example?